Welcome everyone, go back to our class. So today I will introduce about the next part for the one of the course introduction to the quantum computing and programming. Today's lesson is about the essential the quantum gate. So I want to introduce about the the quantum gate, and we'll look how to code in the Colab. Okay. And first is this is kind of actually is six. The essential the quantum gate. If you see in the screen, each gate will be have a corresponding the matrix. You will see over here we have a Pauli. The Pauli gate X is with the corresponding code is X equal to the operator. Is over here we have a matrix 1 and 0. So and if you see over here we have a corresponding matrix. So try to remember this part, okay, because in the next part we often use this kind of code. And we have a Pauli Y and we have a Pauli Z. This kind of operator you can see on the screen. And have one of the quantum gate maybe very common and you often see that's called the Harama. Harama, the gate is symbol is 8. Yeah. And the third one is less common. That's called the phase SP. So it's equal to the operator. This is kind of 0. Yes, this is 1. Yeah. And with include a kind of imaginary part. And the last operator is called T. Yeah, T is this kind of formula in Colab code or the Q-skip code. So you can see this kind of corresponding the matrix. So okay, this is the kind of the essential the quantum gates. So we'll try to see how we can use this kind of quantum gate in some practical example. Okay, here is the one that how you can simulate the vector tensor product 1 and 0, and you can see how to define the quantum the tensor products for 2 qubits or to the dimension vector. So this code can tell you tensor products for the 0, 1, and this kind of code. So I can run directly in the Colab and we'll see how it looks. Yeah. So first, you can copy this code. Yeah. And we'll go to this one, and you can create a new code. Yeah. Please click here and okay, and paste code and click run, and we'll see we have a tensor blocks for 1 and 0 and 1 from our slide. Yeah. And the next part we will have a tensor blocks for the example way from the positive vector tensor block for positive. You may remember the long time ago. We talked about the positive the quantum bit. Yeah. So you see in here we have remember we have positive is equal to the matrix 1 over square root 2, right? And 1j over square root 2. This remember in the previous one, the lesson we already mentioned about this one. And to support calculate the tensor products, we can have one new function. It's called the vector plus tensor, and the input is the state vector. You see this guy of the common. Yeah. This guy of the common. So remember this kind of function. So after you run this code, it will show the result, and I can show you directly in the screen. Yeah. And you can create a new code. Click here and click run. Yeah, you see this is mathematics formats for the tensor products. After you input about the one state vector, this called the state. This one is positive. Yeah, positive. You can change this one to the negative. You can change to negative and see how the result looks. Yeah, you can run again. Yeah. So you will see over here after you change to negative, so the value will be for this part will be changed to the minus. Yeah, minus. So to indicate it's different from the the positive. Actually, that's kind of opposite dimension. Yeah, you will remember about the negative. Negative that mean about the right, and sorry, not positive, that is the right side, and negative, that is the left side. Yeah, left side. In the block sphere or quantum sphere. Yeah. Okay, go back our lesson. So over here, that is how you can simulate about the vector tensor product for the one state vector. And if you want to make a tensor product for two matrices, so you can use this kind of command in the simulation. Remember in the screen we can define this first vector. Yes, this first vector of first matrix. You can have a matrix. This one two dimension, and the second the matrix identity. The matrix will have the same dimension, and we can add check the tensor product for these two vectors by you can add the first vector name for this one and plus tensor, and the input that from the second for second matrix. And over here the result after you calculate about the tensor product for two kind of vector. And that's a very important thing I want to make remind you for notice. That's if we input the two dimension and two dimension for input, so the output need to have a same dimension. So you see this one is input two dimension. Okay, that is very so this is the input and output need to have a same part. Okay, the last thing about the we can calculate about the matrix tensor products by the common evolve. Evolve. So this is a similar level. We have a tensor product. Yeah, this one tensor equal to this this symbol. So you can I can attest for you. Yeah, I can attest. So you can attach by add a new code. Yeah, the new code. Remember this one, this operator require to the matrix. So make sure you initialize the value for two vector first. Okay, you will run this one and do not have this kind of the variable. So it would not work. Yeah, it would not work. So okay, try to click start, and you can see over here we have a new value for the tensor products, the matrix tensor products for to the vector. Okay, to the vector, and this one you need to make a kind of space between this one. Okay, to make sure it's look good. Okay. So the next part we will look more complicated. Here we can calculate about the negative, negative and positive. So negative qubit is called. If you see over here, we have a state vector 8. Yeah, include 1 over square root 2. This one. This one is a kind of positive qubit. And this one we have minus, right? We have a minus. So yeah, this one, and this one is Yeah, remember this part. So we have a positive and we have a negative, and we make tensor products for two the vector, and this guy result. Yeah, if you see this one result is look by quite a little bit complicated, but it's the same two dimension. Yeah, two dimension, the same dimension. Only different about the value in the decimal. Yeah, it's a different. Okay, so in this lesson, I already introduced about how you can simulate matrix tensor products, and you can calculate or compute the matrix tensor products for two the vector. And I hope after this part you can know how you can add some essential the quantum gate to the one vector and try to calculate and compute tensor products. Okay, thank you everyone.